Well, I know how much you guys like the spray welding, and I think I have a spray welding candidate here in the shop to do. So this, what's really cool is that this job right here that I have to get done actually was sent to me because of my spray welding that I showed on the channel there. So I had a nice company reach out to me and ask me if I would be interested in helping them with a spray weld repair on this shaft right here. This is a This is a pretty expensive shaft to have to replace because of the way it's designed. It's got this, it's all one solid piece. It's got this flange here. Turn around so you can see the back side there. So you got some kind of register on this side right there, where it registers here on this fit and bolts up. And I did not go into details on what exactly the shaft is for, but I do know that it's it's a company that deals with pumps and pumping systems. So this is probably some kind of shaft out of one of those, one of their industrial pump systems right there. And what's happened is this bearing journal is worn down, and this is what they asked about was if I could spray weld that for them. That's the repair they were looking for. So they got it sent down here. Matter of fact, this is the tolerance that they give me that they wanted this bearing fit to be machined within, plus or minus 3/10 on that size. All right, so upon inspection, as soon as I started looking at this thing, I noticed there's a real sharp edge right around the shoulder, right behind the threads. And I got in there looking at it real close, and it appears to be a speedy sleeve on this bearing fit right there, which to me is not a very good repair. I know that they're good in the field when you're trying to do an emergency repair, especially on an oil leak or something like that, but just not really an ideal fix. And it's severely worn down. So matter of fact, we're at 3.936, and I know I'm already about 10 to 12 thousandths under that, which is quite a bit. So right there I'm getting about 923, 924. So yeah, about 12 thousandths or so under. The problem that poses for me, as far as doing a spray weld, is that it's already going to be undersized some. So I'm going to have to, it's really kind of throwing me off since the sleeve is that far under. I don't know why the bearing journal is going to be that small unless somebody turned it and put a sleeve on there. So depending on how thick this sleeve on here is, I may not be able to spray weld this because you have a tolerance there of how thick your buildup can be whenever you do a spray weld. So if it ends up being too small for the spray weld, what we'll do is just turn it down to just above the diameter of the threads, and then we'll machine a heavy sleeve and shrink a sleeve on there and then turn it back to size. But I won't know until I get it in the lathe and start turning this off. I can tell that it's very thin. I can just feel an edge sticking over that shoulder there with my fingernail. So hopefully we can just knock that off and it'll still be within size to do a spray weld. So anyway, that's the repair job. Let's go ahead and jump to it. Just inspecting the center there. We've talked about this before. Sometimes the center has been hit, somebody's hitting on the end of a shaft with a hammer. It'll mess this up, but it appears that it hasn't been marred in any way. It's just rusty and corroded. So I'm going to polish the end of the shaft off with a side grinder there, a polishing wheel, and then get in there with some emery paper and just hand clean the center out before we go to the lathe. I'm still getting used to the fact that I've got a nice parts washer back here, the CRC Smart Washer, and I was cleaning these threads off and that little bit of grease that gets packed around those shoulders there. So I brought it back here, and this is doing a good job of getting all that stuff out of there. So I love having this new parts washer, man. It's awesome. These next few clips, I
somehow lost the audio in there. Something happened to the audio in the video, so I'll just kind of talk you through what we're going to do. So what I'm demonstrating here is the importance to presetting your chuck and getting your machine ready for the workpiece, especially when it's a big heavy workpiece that you got to bring down, you know, tote down and install into the chuck. So get your jaws preset. I had them preset there so that I can stick it in there and, you know, push it over into the chuck and then tighten the top jaw down so that it holds the workpiece. And once you get the top jaw tightened and the piece is secure into the chuck, then you can move down to your tailstock and push the tailstock up in there lightly enough to where you know that it's going to hold the workpiece to keep it from falling out of the chuck. When you come back around here and tighten the jaw in front, you can see that it just moves a little because I didn't have it fully centered up when I stuck it in there. That's the importance of having the tailstock in there just to hold it. If I didn't have that in there, it would have just fell over. So once you get it in there like this, go ahead and install the soft jaws. These are just some brass, thick pieces of brass shim stock that I have cut, and you put those between the jaw and the workpiece, and provides two things there. It keeps from marring up the workpiece, and it also adds a little bit of slippery surface there so that the jaws aren't grabbing so hard on the material and keeping it from moving around, because this workpiece here we're going to have to bump and indicate, and if you get those jaws too tight on the metal surface there, it gets really hard to move. So you need to have it to where it'll slide around a little bit. So brass, copper, or aluminum, they all work great for soft jaws. That's just what I call them. So we're just going to initially get it kind of trued up here. This isn't the this isn't going to be the final indicating. This is just getting it centered, and once we get it kind of somewhat running center, then we're going to start checking the flange face and moving to each end of the shaft, getting it true.
All right, I'm going to go from there. Since we're within 1 thousandths right there, let's go ahead and move it. And let's see. Let's go ahead and check it out here on the outer end. All right, notice I swapped out my indicator tip here for the wide radius, and that's so that we can sweep over this big keyway here without a bunch of issue. So we're not going to put much preload on this here. Yep, see, I'm definitely crooked, so it's doing this in the chuck there. I don't have it straight yet, so we're going to have to. What I really need to do is make sure that this end down here against the chuck is bumped up true first, and then we'll go back to our indicating. All right, we got it up here on the flange, and you can see. So I'm at about 13. Let's see, it's 12. About 15 thousandths. So we need to bump this around. That'll put us a lot closer. That's within 1, 2. All right, now we can do our ODs. So we're going to go ahead and start on this end right here, closest to the chuck. So we can make sure that this end is indicated, and then we'll move out here to the outer end. All right, so that's our high. I'm going to bring it around and give it a little tap. And we've got it within, looks like 1.5 now. That's real tricky to get out. Let's just lightly bump it. That's our high. If you don't get it out though, and you run the center in there, it's still going to be moving out on this end. So you got to get it running true before you put your center in there. Now back to the other side. I think that might work right there. So what I'm going to do now that we've got it real close, we're going to run the center up in here. It looks like we got it less than 1 thou, so I think we're going to be able to live with that. I did some more tweaking with the camera not rolling just to get it out of my way so that I could get in there and more comfortably indicate this. So we've got this in a 1/2 thousandths. And then if we come down here to the seal journal, let's put it here. It's like a 1/2 thou there. So we got this thing running nice and true, and we are ready to start cutting our journal now. We're going to use this tool here, this MCHNN, and I want to try to get an idea on how deep that sleeve is. Let's just come right here in the middle somewhere. I'm going to set a 0. Well, that's already 50 thousandths right there, so I may be mistaken on a sleeve. This could be just rolled over, the metal rolled over that far. That might be all it is that the journal is just worn so bad that it just rolled over. I was just cutting a bevel there to cut that edge off. That might be just solid material. In that case, let me get in there and do my proper undercutting that I need to do. So I'm going to go ahead and prep it like we're going to spray weld it, and then do my undercut. And if I am mistaken that it is a sleeve in there, as soon as I start doing some preheat here, you'll see it start heating up, and I'll know that I got to stop and just go ahead and turn that off there. So I'm going to go ahead and coat the threads real good. I hate cleaning that stuff out of threads. And then we're gonna get this area right here good too. All right, so I'm gonna let that dry, and then I'll start doing my undercut. We're gonna go ahead and carry on with our undercutting, and I ground up this high-speed tool right here. And the purpose of this is that I can get way over close to that shoulder with this tool right there. And this is the proper angle that you should have on the sides is 45 degrees, or a tool with a 90-degree included angle. So we'll touch up both sides with that, and I'll be able to get in there. Just gonna go as far over as I can get. Right about there. We're going to take it down about 50 thousandths total. I am going over that keyway in case you're wondering. And I don't want the chips to scratch my masking there. So that deep groove in the middle will be fine. What we'll do is we'll just we'll build that up first. As long as you've got a deeper groove in the middle, and you're not doing the whole thing at a depth beyond what you're supposed to, it works fine. Finish this thing out with our high-speed tool. Just get our touch off so I know I'm going about the same depth. All we got to do is just touch it really. I'm going to try to get as close as I can to that shoulder, so right about there. Going in with my threading tool, and we're going to make one scratch pass with this. Gonna touch off and go in about 15. Waiting on my dial to come around. There we go. So there's our journal ready to spray. Undercut, threaded. So we got a little setup to do with my torch. I get it over here, and once I'm ready, we'll start spraying it. I've been holding on to this real nice, barely used Eutectic kit. I think I want to go ahead and put it to use. We got a torch in here that looks like it has been very little used, and it is a vintage kit. This thing is several decades old, but it is in beautiful condition. I can pull it out of there. This is what you use if you want to hold it in a lathe in a tool post right there. Look at that guy. It's in great condition. There's the torch barrel there. And we even got plenty of the powders up there. This being the one that I use on all my buildups, the 19985. Still a bunch of it in there too. So I want to set this guy up. I'm gonna test it first before I actually start spraying and make sure that it's working good. And probably use that one there. And on the inside of the lid there, this gives you all of your information on how to properly spray. Everything I've been talking about in my videos is all right here on the back of this this lid, on how to undercut it, and then how to preheat it and coat it, and then machine it. Pretty cool stuff. And then this this right here is the silhouette. You lay the torch over that to make sure that your adjustments are correct on your tube and your torch tip. All right, well, here we go.
Okay, hold on. Go ahead.
Get the torch regulated. Alright, so we got to get our preheat done first. Get the base metal up to 200 degrees. What's the matter? Big chunk of steel here, so it takes a minute to get it hot. temps. We're going to use our bonding coat right now, our bonding powder. We're going to go on with our buildup coat. I got to get rid of that overspray there. It's kind of getting in the way of the powder, so I just knock it off as it forms. See about where I'm at now. Ways to go. How's it looking on the new camera? Knocking that overspray off again. Get closer. Okay. about 20 thousandths that I need to get it built up. Plus that little groove in the middle there. Get in this corner. I'm a little bit low on the corner, but looking good about there. All right, almost. We got it. That should be good.
Is that how hot I am? Maybe it's measuring me.
You're 91 degrees.
Don't touch it. It's 300 degrees.
I'm going to go ahead and clean this up right here using the grinder. I got my fume extractor on too. Forgot my earplugs.
I said this before, but I just want to reiterate it. What I usually do after I pull the fire cloth off, before I move the carriage, I go ahead and wipe all of the ways down just to remove any of the dust that falls down on it, because I use that fire blanket for, of course, spray welding and other jobs too. So there's dust on the blanket that'll get down there. So I always clean the oil off first so that it doesn't like stick to the ways with the oil, and then wipe them off real good. And I just take my oil can and just put a little bit more oil in there. So yeah, now we're ready to go. I really have always liked using Micro 100, and the last spray weld job I pulled these two out and we used these, so I'm going to go ahead and use them again for this job. These are the 3/8 brazed on carbide tools, but I think that the Micro 100 brand is a good high quality grade of carbide. And it's not like the old school where you had different grades to, you know, for if you're doing cast or steel, whatever. This is kind of a one grade fits all type application. So just good quality tools in my book. And this is just where I had restocked my supply, you know, different sizes and different types, you know, for threading and chamfering, right, left hand, you know, 1/4 inch. Use these like in the board and bars. So anyway, we're going to use the Micro 100 today. I'm going to start on the inside and cut from left to right to get rid of this raised area there. And then once we get this area kind of cut down, then we'll go from right to left. And we're running approximately 100 surface feet per minute. We'll see how that does, and if if it starts burning up the carbide, then we'll slow it down. Don't take big heavy cuts with it either. 10-15 thousandths really is all you need to take at a time. See, that's that groove that I had cut in the middle there. Okay, let's see if I drag across here a little bit. Yep. Come back into my 0 and we'll clean this side up to match it there. I got my compound turned around here on 45 degrees, and I want to come in there with the compound and hand feed this edge right there where I've got that chamfer machine and that powder is rolled over, and that's the proper way to do that, is to take little cuts instead of coming in there and trying to cut that all at one time. It could peel that off there, so you just want to make little cuts with it. Okay, so we're down to our last 10 thousandths and it's looking real good. It's uniform all the way across. So what we'll do is I'm going to speed it up now and take some light cuts to try to improve the finish and get it down to where it needs to be. 264 RPM right here. We're taking a 5 thousandths cut depth and a 5 thousandths feed rate, and you can see how it improves the surface finish there. And it really only works on the finished cuts like this when you're taking a very light cut. If you run this speed when you're trying to rough it, it seems to burn the tip of the carbide off. So you got to keep it on the slower speeds when you're roughing. All right, I believe that was my finished cut, so let's see. Yes, so that's going to give me 8/10 to polish down to bring it to our high end of our tolerance right there. So we were shooting for 3.937, and we're at 938. So really, that gives me 8/10 to polish it down. Awesome. All right, I got some 220 and also some 320 grit emery cloth, and that's what I'll use to give it the final polish. And I'm going to go ahead and just rip that one side off. You need to be completely flat on the journal, or it'll just pull hard on the side. You see I got the ways covered up, so sometimes this doesn't take much. You see that powder coming off there, that dust? That's the high spots of the tool marks. And sometimes whenever you do that right there, it'll take it down a few tenths instantly. So you just got to hit it a little bit and check it, because you can certainly go too far very quickly if you're not careful with it. So I took it down, it looks like 3/10 right there. Yep, took it down 3/10. So I really don't have, but let's see. We got about a 1/2 thousandths to come off of it now. I'm checking both ends to make sure that I'm staying straight with my polishing. So we're at 937 and 5/10. So I got 3/10 to come off. All right, so you can see this works pretty good once you get it down to that last thousandths, and it's looking nice and pretty too, polishing up real well. So I'm gonna finish getting this polished up and bring it back. I don't want to keep showing you the same polishing footage over and over again. I'll come up here with some Scotch-Brite and we'll brighten all this up right here as well, and then we'll polish the shaft up, make everything look good. All these pipe marks on here, we'll stone them, make sure there's no high spots on there. And I finished it at 937 and 2/10. And that's on the high side of this tolerance right there. Come back here and check the back side. And it's exactly the same. Journal is finished. Now it's just on to finish polishing the rest of the shaft there. I'm real happy with the way it turned out though. It looks great. You see right in here where the keyway is, and the powder didn't stick down in here because I had the masking in there, but you can see how it kind of builds an edge up around it. So I'm going to use this carbide burr right there and very easily come in there and just touch the edge of that keyway and kind of cut it back, and then put just a slight amount of bevel right on the edge. Go ahead and give the seal journal a nice polish in this area. You can see when you hit it with the paper, you can see right where the oil seal was running, right there in that groove. And this is a common repair for the spray welding. Instead of the bearing journal, it's just a seal journal. Now this right here, and you can't feel it with your fingernail, so it's not very deep. If it is, it's just very, very minute. But you can usually just take your paper and especially just cut a little thin strip out of this. So we'll just narrow this into something like that, and you can come in there where those grooves are. A lot of that, what you're seeing, is actually a little bit of corrosion back behind the seal. But you can hit it like this and just kind of polish that groove out of there. Just like so. And the cool thing about an oil seal is that, you know, it expands. So if you're off a little bit on this, even a couple thousandths or more, it's really not going to hurt your oil seal on your diameter. So just come in there like that and just Just give it a couple hits with some thin paper and just blend that little mark right on out of there. Come in there with your wider piece. And you got a nice polished up seal journal right there. And I removed very, very little metal off that shaft right there. I'm going to use these precision ground stones here to make sure that those pipe wrench marks aren't sticking up. Looks like they did a pretty good job of filing them off there. You got that one spot right there. It looks like maybe a set screw is dogged down on there, and I can feel it when I rub the stone across. It catches it. So there's a little high spot in there, and I can certainly see it now. Now that I'm rubbing it, it really polishes the high spot over. And it looks like it's right where it needs to be now. Now when the stone slides across, it doesn't catch it. There's one more right there. I think we are good. It's ready to go out of the machine now. What I'll do is I'll just come back and collect the brass. I'm just going to loosen it up a slight amount like that to get the torque off of it, and snatch it, hold it up with my hand here. I'm going to come in there, cradle it just like that, and go on out. Well guys, this job is completed and it's finished up. Only thing left to do is I'm going to coat it down with some rust inhibitor and then get it strapped back to the pallet that it was shipped on, and get it down to the shipper and get it headed back to the customer there. So I know a lot of you guys watching the channel really like this procedure and seeing the videos on the spray welding, and I enjoy it too. That's one of the reasons why I do it, is because it is something that is a lot less common these days, and it's really more of a specialized process that you don't see very much of. You know, out there in the industrial world, in these different, you know, big plants and places like that, they use processes like this. It's just not something that's very common that you would see, you know, in the everyday world, or especially on YouTube. So I really do enjoy sharing that process with you, and you know, and I enjoy doing it too. I get a lot of people that when I share the pictures on Instagram or even the video here, you'll get, if you read through, you'll see comments, you know, the guys saying, why not just sleeve it? You know, it'd be faster if you just sleeve it. And I wanted to point on that for just a second as well. This process was developed by Eutectic, I mean, long time ago, you know, decades back. And it's a tried and true process when it's applied correctly, whenever it's done correctly. If you do not do it correctly, then you will have problems with the, you know, the buildup not wanting to hold like it should. But if you go through the procedure like Eutectic tells you to, I have never had one of these spray welds fail, as far as I know. I've never had a customer come back and say, one of these have failed, we need you to fix it, or it's caused damage because of a failure, things like that. I have heard of that happening, and that's why some people want to stay away from it, because they had a failure, and I think it's because it wasn't applied correctly or used in the correct form. Okay, you have a wide range of powders for different applications. This one that I spray right here is perfect for a bearing or a seal journal if it's in a captured state. So if you was to say you had a good example is a needle bearing. if you have a needle bearing that's rolling across a journal, you cannot use this type of powder for that. You're gonna have to use a different type of system. But if you got a bearing like a ball bearing, you know, with an inner race that's going to be shrunk down and held on that, that's what this particular powder is used for. There's other ones that are harder, and there's other processes that you can use if you need to build up a surface that's going to be used as an actual bearing race. But whenever you have this system set up, you know, I'm not set up to do it every single day, so I move everything down to the lathe. But if you have all this set up ready to go in your shop, you can do these repairs right here on a fit, a journal like this, in half the time that's going to take you to turn it down, find a piece of material, go to another lathe, if you have another lathe, machine the sleeve, and then shrink it on there and then turn that down. That's one of the reasons why I like using the spray welding processes, because it is a time saver, and that's why they developed it, to help save expensive parts like this. You know, this is just one example, but to help save expensive, hard to replace parts, and also the downtime. So you can get these done in a less amount of time than it would be traditionally to put a sleeve on there. Or a lot of guys say, why not just weld it up? The problem with welding is that you create so much heat in this parts that you make it warp, you draw it. So it's not going to stay straight. This is considered a cold process, so it doesn't reach the temperatures that's going to cause this thing to warp or draw one way. It's going to stay completely straight. You're not going to harm anything on these. All right. So I enjoy doing it. I enjoy sharing it here on my channel, and I think my viewers enjoy seeing it as well. And I'm going to continue to show this whenever I get some good projects in here. And I wanted to go ahead and touch on what this specific job is for, because I've had a lot of times, you know, throughout my videos, people wondering, what does it go to? You know, well, I'm not out there in the field, so I can't see these things go back into service. But my customer gave me a little bit of info, and I didn't ask him if I could mention who it was, so I'm not going to mention who the customer is. But this goes to a positive displacement blower, and it's used to move gas or fumes from a burning process at a chemical plant. All right, so that's what this goes in. It's part of the drive system for a big blower. And this customer that is doing the repair on this, he gave me a little info about what they do out there in the field. He says that they build pneumatic conveyor systems, and they also fabricate entire blower assemblies for these different plants. And they build sound enclosures to go around them as well. And then of course they also repair pumps and blowers like this right here. And they're also a distributor for the Tuthill brand blowers. So that gives you a little idea right there. Hopefully I got a picture that I can share with you on screen to kind of give you an idea of what it looks like. And other than that, I hope you guys enjoyed the video, and come on back for some more. Hopefully I have some more of this good spray welding footage to share with you in the near future. All right, see ya.